Okay, we are going to go over the review for geometric solids. The first topic we are going to review is nets. Okay, nets are like if you fold up this flat shape, you would end up getting a 3D solid. So this review says identify which solid you would get. Okay, this solid here has two circles and a rectangle. This would end up being a cylinder. Okay, this is like the lateral face. This would be a base, and this would be a base. Okay, so that would end up being a cylinder. This one is going to be a cone. This is the base, and if I were to fold this along that base, it would end up looking like a cone. Okay, they have rectangular sides, and they have, this one has two pentagons. These pentagons would be the base, and these rectangular sides would be the lateral faces. So you name a prism by the base. So it's not always the bottom, it's whatever the base is. And the base are the two congruent sides that are parallel to each other. So this one and this one, if I were to fold it up, would be the bases. They'd be parallel and congruent. So this is a pentagonal prism. Okay, a prism has lateral faces that are either going to be rectangles or parallelograms, depending on if it's a right prism or an oblique prism. Okay, the pyramids down here, these have lateral faces that are triangles, and there's only going to be one base. Okay, so this one is going to be a pyramid. We name the pyramid by the base. This base has 6 sides. If it has 6 sides, that's a hexagon. So a hexagonal pyramid. Okay, if we look at this one, there are rectangles here and here that are congruent to each other. So we can call this a rectangular prism. Okay, all of the lateral faces are also rectangles. This one, our base, is a rectangle, and the other faces are triangles. So this is going to be a rectangular pyramid. Okay, cross sections. Cross sections are when you cut through a shape. Now, sometimes your shape that you're using to slice the solid might be parallel to the base. It might be perpendicular to the base. It might be on an angle. Okay. In this example, this is where the figure is cut. It is parallel to this side. So it's going to take on the shape of that side, and that side's a rectangle, so the cross section would be a rectangle. If you were to cut it in a different direction, and let's say you sliced it going a different way. So let's say I took it and I sliced it through here instead. If I sliced it through there instead and made it parallel to the base, because the base is this triangle, then I'd have a triangle for my cross section. Okay. It just depends which way you're slicing it. All right, so down here, identify what shape the cross section would be if it were sliced by the quadrilateral in the indicated position. So it's saying this is what's slicing it, that's what's cutting it through. So if I chopped it off, okay, this figure in a cone, what I'm using to slice it is running parallel to the base. So any cross section that's parallel to the base of a cone would be a circle, because the base is a circle. Okay, in this figure, we have a pyramid. It's being sliced this way. this is parallel to this base. So even though this shape is a rectangle that's slicing it, when you were to cut this off, it would be the same shape as this base, because all the way up here, if you were to slice it, you would get a bunch of little hexagons stacked on top of each other. So this is going to be a hexagon. Okay, so if the cross section is parallel to the base, it's going to be the same shape as the base. Okay, your solids of rotation. You can rotate a polygon around a line and then end up with a geometric solid. So like in this example, we have this line here, and we're saying we're rotating this. So if you spun it, like this picture shows, if you spin it around and around and around, you'll end up with a cone. Okay, in this figure, this is our line that we're rotating on, and we're going to spin this shape around and around and around, right? So if I took we're basically going to cut this into two pieces, right? I'm going to cut this like this, okay? And let's look at it separately. So if I cut it right here, I would have this triangle on the top, and if I spin that around and around and around, that part's going to make a cone, okay? Now if I take this bottom half, or the bottom portion, and it's a rectangle, okay? If I spin a rectangle around and around and around, and I go like this, right? I'm spinning it around. That's going to make a cylinder. So what figure would I get? I would get a cylinder with a cone on top. Okay, it would be a cylinder with a cone on top of it. All right, let's go on to the next page. The next page, you're going to want to refer to your reference sheet, your sheet of formulas that you guys have, if you don't already know your formulas. What is the volume of a cylinder with a radius of 6 centimeters and a height of 10 centimeters? So volume of a cylinder. So depending on what your reference sheet looks like, you might have volume is equal to the area of the base times the height for a cylinder, or you might have it filled in that because the base is a circle, we would say pi r squared times h, because the area of the base is the same as the area of a circle. So you can fill in pi r squared there. All right, so we're going to see what we have. We have a radius of 6. So we have r is equal to 6 and a height of 10. So h is 10. So if I plug this in, volume equals pi times 6 squared times 10. If I follow order of operations, I'm going to take care of my exponents first. So I'll have pi times 36 times 10. And then I would multiply together. So I would have 360 pi. And I'm in centimeters, so I would put centimeters cubed at the end of that. Now, this did not say to leave your answer in terms of pi or to round. So if on your test it says to leave in terms of pi, you would leave it like this. If it said to round your answer, you're going to want to use 3.14 for pi. So I would just have to do 360 times 3.14 to get an approximation for my answer. And I get 1,130.4, and again, it would be centimeters cubed. So it's just going to depend on your test what your directions say. Okay. Number 2, to the nearest square inch, what is the volume of the right triangular prism? So it's a prism, and we're doing volume. So volume is equal to the area of the base times the height. We have to be careful and make sure we name our pieces correctly. This is a triangular prism. So my base of a prism, remember, is going to be indicated by the name of it. And you get the name because the bases are the two congruent parallel faces. So in this prism, the triangles are the bases. So these are my bases. Okay, it's not the bottom always. Sometimes prisms are turned on their sides. You have to pay attention to where the parallel congruent bases are in order to indicate the bases. So I need the area of a base. Since the base is a triangle, I'm going to say 1/2 little b times h is the same as the area of the base. And I'm actually going to make this h here capital H, because it's the height of the prism that I'm multiplying by. The height of the prism is the distance between the bases. So this is going to be my big H, because that's the distance between the bases. Okay. Now in the triangle, if I have to do 1/2 base times height, let's look at our triangle that we have here. This is shown as a right angle, this is shown as 24, and this is shown as 26. If I want to find the area of that triangle, I need base and height to be perpendicular. I don't have this measurement here, I'm going to need to figure it out. This is my base, I'm going to need to figure out this piece here. It's a right triangle, so I'm going to have to use Pythagorean theorem. So I'm just going to call this x. Okay, I'm going to have x squared plus 24 squared is equal to 26 squared. Okay, x squared plus 576 is equal to 676. And if I subtract, I'm going to get x squared is equal to 100. And I get x is equal to 10. So this side here is 10. So now I can figure out the area of my base. I'm going to do 1/2 of 24 times 10. The height is going to be the 15 because it's the height of the prism. Okay, so I can multiply everything together here. 1/2 of 24 times 10, so 1/2 of 240. Half of 240 is 120, and then I still have to multiply by 15. So I'm doing 120 times 15, I get 1800. I'm in inches, so inches cubed. All right, so I have 1800 inches cubed for my volume. Number 3. Number 3. All right, number 3, we have the diameter of a cone is 16 and the height is 12. What is the volume? The volume of a cone is 1/3 the area of the base times the height. The base of a cone is a circle, so we fill that in with pi r squared times the height of the cone. Now, this problem gave us the diameter. Right, so 16 is the diameter. Diameter is not in our equation, so we have to do we have to find the radius. So we have to cut the diameter in half. The radius is 8. So now I can plug all this into my equation. 1/3 pi times 8 squared. The height of the cone is 12. All right, I'm going to take care of my exponents first. I'm going to say my fraction for the last thing to do. So I'm going to multiply the 64 times the 12. Okay, then I'm going to take 1/3 of 768, which is the same thing as saying divided by 3. So you can either on your calculator say 768 times 1/3, or you can say 768 divided by 3. You're going to get the same answer. You're going to get 256 pi. We're in centimeters, so centimeters cubed. Now again, the directions didn't say to leave it in terms of pi or to round. So if it is an exact answer, we leave it like this. If you would have to round it, we would plug in 3.14 for pi, and we could do 256 times 3.14, and we would get 803.84 centimeters cubed. All right, number 4, we have a square pyramid. It has a height of 30 feet. The length of one side of the base is 6 feet. To the nearest square foot, what is the volume of the pyramid? So pyramid volume is 1/3 the area of the base times the height of the pyramid. Okay, this says it's a square pyramid, so we know the base is just going to be the side squared, right? Because the square, to get the area, you just do the side times the side. And it says the side is 6, so we can fill that in. It has a height of 30, we can fill that in. What to the nearest square foot, what is the volume? So I'm going to go 1/3 of 36 times 30. So I'm going to have 1/3 of 1080, and that is going to equal 360. And we're in feet cubed. Feet cubed. And this should have said to the nearest cubic foot, what is the volume of the pyramid? So I'm going to make sure I change that. All right, next one. A sphere has a diameter of 9 inches. What is the volume of the sphere? So volume is equal to 4/3 pi r cubed according to our formula. Okay, I don't know r. I have to figure out r. So in this case, I'm going to need to divide 9 by 2. So r would equal to 4.5. So I have 4/3 times pi times 4.5 to the 3rd power. So I would multiply that in my calculator, 4.5 to the 3rd. And then I would take my answer and multiply by 4 and divide by 3, or in your calculator, you just multiply by 4/3. And you're going to get 121.5 pi, and we are in inches, so it is inches cubed. Okay, it said leave your answer in terms of pi, so we don't need to plug in 3.14. All right, number 6. The radius of a hemisphere is 12 inches. What is the volume of a hemisphere? So the volume of a hemisphere is 2/3 pi r cubed. It says the radius is 12, so I can go ahead and plug in the 12. It says use 3.14 for pi, so I'm going to go ahead and use 3.14 for pi. And I'm going to put all of that in my calculator. 12 to the 3rd power. I'm going to multiply by 3.14, and I'm going to multiply by 2/3. And when I do that, I get 3,617.28. And we are in inches, so it is inches cubed. Okay, number 7. Given that the volume of a rectangular prism tank is 1,920 inches cubed, and the length of the tank is 8 inches, and the width is 20 inches. How tall is the tank? So rectangular prism, we're thinking a tank like this. Okay, to do the volume of this, we do the area of the base times the height of the prism. The base is a rectangle, so you can say length times width. So length times width times height to get the volume. It says the length is 8 and the width is 20. We know the volume, so we're going to say 1920 is equal to length times width times what we don't know, h. So I'm going to multiply the 8 times 20. I get 160. And I would need to divide both sides then by 160 to get my missing height. So I have 1920 divided by 160, and I get 12. So 12 inches is the height of the tank. A square pyramid has a volume of 720 inches cubed. The side of the base is 12 inches. how tall in inches is the pyramid? So volume is the air 1/3 the area of the base times the height. Since it is a square pyramid, you do side squared for the base. We fill in what we know. The volume is 720. So 720 equals 1/3. The side of the base is 12. So 12 squared times the h we don't know. So I'm going to do 144 for my 12 squared. I'm going to take 1/3 of 144 to get 48. So now I have 720 equals 48h. And I'm going to divide both sides by 48. And I get 15 is equal to h. So the height of my pyramid is 15 inches. Okay, next page. We have ooh. Hold on 1 minute. All right, find the volume of the composite figure. So this figure looks like half a cylinder on top of a prism. So we need to think about what we're putting together. We have a prism plus half a cylinder. So the prism, it's a rectangular prism. So I'm going to do the area of the base times the height. It's going to be length times width times height because it's a rectangular prism. This cylinder, I'm going to take half of the area of the base times the height. And when you have a cylinder, it's pi r squared for the base because the base is a circle. So this is all the information I need. So let's label what we have. Length and width, you can call whichever one you want. It doesn't matter. So if I call this one L and this one W, the 6 is the height of my prism. I need to figure out what the radius is of my prism or my cylinder. So if this distance is 9, then that would mean from here to here would be half a 9. So that would be 4.5. So R is going to be 4.5. The height of my prism, or sorry, the height of my cylinder is going to be the distance between the bases. So that's going to be 11. So here I'm going to go 9 times 11 times 6 plus half of pi times 4.5 squared times 11. Okay, so let me do the prism part first. We're going to do 9 times 11 times 6. We get 594. Over here, we're going to have to raise 4.5 to the second. Multiply that by 11. And then I'm going to go ahead and multiply by 3.14. So I get 699.435. And then I'm going to go ahead and have to take half of that. So I get 349.7175. We can add our two answers together. And we're in millimeters, so millimeters cubed. Okay. For number 10, we have find the volume of the figure. The smaller cylinder is removed from the larger. So it's basically, it looks like a toilet paper roll, kind of. It's a cylinder with another cylinder cut out. So we're doing cylinder minus cylinder for this one. If something's cut out, you're gonna have to subtract. Okay, in the previous question, we were putting two figures together, so we added them. But this one, something's cut out, you're gonna have to subtract. So we're gonna need pi r squared times the height minus pi r squared times the height. Now, in this case, we're going to have a big radius and a little radius. So you can see on here that this big radius is 34 and that the little radius is 15. We're going to do big minus small. So when I fill this in, I'm going to have pi times 34 squared. The height for both of them is the same, it's 40. And then we're going to have pi times the little radius squared times the 40. So we're going to have 34 squared times 40 is going to give us 46,240 pi minus 15 squared times 40 gives us 9,000 pi. I can subtract these two because they both have a pi in them. They're like terms. So 46,240 minus 9,000 gives me 37,240 pi. And we're just going to say units cubed because it didn't tell us a specific measurement. Now, if it said to round, then we would plug 3.14 in for pi. And we get 116,933.6 units cubed. All right, surface area. Now, surface area is different than volume. Okay, volume is like what you can fill in something. Surface area is like what you can cover. Okay, it's a two-dimensional measurement, whereas volume is a three-dimensional measurement. Okay, number 11, what is the surface area of a rectangular prism that has a height of 5, a length of 9, and a width of 8? So if you just sketch it, it might help you. So it says there's a height of 5, a length of 9, a width of 8. So the easiest way probably to do surface area is to figure out the area of all the sides and add them up. So if you look at this, the bottom and the top, so this one and the one that's on the bottom down here would both be 9 by 8. I have two bases that are 9 times 8. This space on the side here would be the same as this space over here. And those are 8 times 5 or 5 times 8. And then you have another one. You have the front and the back that are the same. And those are going to be 9 times 5. Okay. So then we're going to multiply all these together. So I have 2 times 72. I have 2 times 40. And I have 2 times 45. So the 2 times the 72 is going to give me 144, plus the 2 times 40 is 80, plus the 2 times 45 is 90. And then I'm just going to add all of those up. When I add all those up, I get 314. It's going to be inches squared. Okay, it's surface area, so they're in units squared. Okay, a cylinder has a radius of 8 inches and a height of 10 inches. Leave answers in terms of pi. So I have a cylinder. I have a radius of 8. I have a height of 10. I need to know what my formulas are. Okay, this says what is the base area of the cylinder. So the bases of a cylinder are the circles. Okay, so I have 2 circles. So 2 times pi r squared. So in this case, it is 8 for pi. So I'm going to have 2 times 64 pi, which is going to give me a total of 128 pi. So that's my base area. And again, we are in inches, so inches squared. What is the lateral area of the cylinder? The lateral area is going to be this thing that's wrapped around the cylinder. Okay, if you flatten that out, it's a rectangle. Okay, it has a height of 10, and this distance is the circumference of the circle, which is 2 pi r. So when I do lateral area, it is going to be 2 pi r times 10 in this case. So lateral area is going to be 2 times pi times 8 times 10. So I have 160 pi. And again, it's inches squared. Now, what is the surface area? Would be putting those two together. So I would just add my two up, total together. So 128 plus the 160. So I have 288 pi inches squared. Okay, surface area of a sphere. Surface area for a sphere is 4 pi r squared. Diameter is 9. So if diameter is 9, radius is 4.5. So 4 pi times 4.5 squared. So 4 pi times 20.25. So I have 81 pi, and I'm in inches, so inches squared. If it asks me to round, I would plug in 3.14, and I would round my answer. All right, the last one is a square pyramid. It says the slant height is 15 inches and the length of one side of the base is 18 inches. What is the height of the pyramid? So if you notice, slant height is the height that runs down the middle of the triangle. Okay, that's the slant height, that's 15. The length of one side of the base is 18. So this is 18. What is the height? The height of the pyramid goes from the vertex of the pyramid to the center of the base. So if you notice, there's a little right triangle here that's formed. Okay, this is a square pyramid. So if this is 18, halfway across the base is going to be 9. Okay, this little right triangle looks like this, 15, 9, and our missing height. We need to use Pythagorean theorem to help us figure out our missing height. So we would say 9 squared plus h squared is equal to 15 squared. So 81 plus h squared is equal to 225. Subtract the 81 from each side, and we get 144. And then take the square root of both sides, and we get 12. We're in inches, so 12 inches.